Okay, greetings physics fans. What we're going to do today is we're going to test this idea of conservation of momentum for three types of problems. The first problem is the explosion, which is one we did before, and then we're going to do two collisions. One collision where they bounce off each other, and one collision where they stick together. And what we're going to try to do in this, the goal is use the idea of conservation of momentum, knowing the initial velocities of each, knowing the initial momentums of each, we can figure out the total momentum. If momentum is conserved, if we know all the momentum we start with, then that means we know all the momentum we end with. And if we know the momentum of one, and we know the total, we can figure out the momentum of the other. And if we know the momentum of the other and its mass, we can get its velocity. So we're going to make a prediction. That's the idea. We're going to know the initial conditions, and we're going to know the momentum of one of the carts, and we're going to predict what the momentum of the other cart will be and what its velocity. Then we'll see how it matches with the data. And we're going to do this in three different scenarios. Okay? And where you're going to put your information, your answers, is on the survey that's on the link below this video. Okay? All right. And absolutely feel free to pause and rewind this as many times as you'd like. Okay? So, here we go. Let's start. Just as a little review, as we set this thing up, this is cart 1. And, whoops, let's get this going. Okay, this is red. 1 is being measured in red, 2 is being measured in blue. I'll do the blue again. Here's 2 in blue. So this is 2, this is 1, and when things move to the right, there's positive. When things move to the left, there's negative. Okay? So, here we go. Let's do our explosion. We'll start collecting our data. Boom. Okay? We've got our data. Looks pretty good. Looks pretty good. All right. So these are the parts that we want. One thing to notice, red is the heavier one, blue is the lighter one. Notice the red has a velocity around here, blue has a much larger velocity here. Red is positive, blue is negative, positive is that direction. So let's see what we have here. Let's start filling in our givens. So let's see here. First, let's go over to this window. All right, so we're going to make this our unknown. We're going to look at these guys, look at this, and look at this as our unknown. Now, before the explosion, everything starts at rest. Okay? We've got M2, which is the blue, at rest, initial velocity of 0, and we have its mass of 0.51 kilograms, and M1, which I measured earlier, both of these, is 1.02 kilograms. Okay? So, what we have, looking at this, first thing I want you to do is to calculate its initial momentum. Okay? So, momentum, remember, is mass times velocity. So, M2's mass is 0.5 kilograms. And before the explosion, it was at rest. Use the equation for momentum to calculate the momentum of cart 2 initial. Okay? Let me change the color on that. And you're going to do the same thing with cart 1. Cart 1 initial, mass of 1.02 kilograms, initial velocity of 0, calculate its momentum. Feel free to pause while you do that calculation. Okay? All right. Now we want to know the total amount of momentum before the explosion. So you take 2's initial momentum and you add it to 1 initial momentum, and that gets you a total momentum that you start with. Okay? So take this momentum, add to this momentum, that gets your total. I'll pause for a moment. Okay? And Now we want to know what's happening afterwards. So let's figure out what's happening afterwards. Let's find out what cart 2's velocity is afterwards. So cart 2, that's this guy. So what I'm going to do is I'm going to shade that region right there. And I'm going to go to stats. And I only want velocity 2. So I'm going to hit OK. And I don't know how well you can see this in the video, but it is, I'm going to round, negative 0.63. It's negative because it's moving in the negative direction. So we'll put that in our table, negative 0.63. Meters per second. So the mass is 0.51 kilograms. The final velocity is negative 0.63 meters per second. Take a moment to calculate the final velocity. Okay? Pause it if you need to. All right. Now we know the final velocity. I'm sorry, the final momentum. Let's look at it over here. If we look at this guy over here, we want to figure out what P1's final momentum is. Well, if momentum is conserved, all the momentum we started with should equal all the momentum we end with. So, if we know all the momentum we end with, and we know 2's final momentum, we can solve for 1 final momentum. So we know this because this is the momentum we end with, which it has to be equal to the momentum we started with. We know this because we just calculated it, which means we know what this is. Okay? Now what we're going to do is go ahead and solve for what this guy's velocity should be. So we know its final momentum. We know its mass, 1.02 kilograms. We can do algebra, divide both sides by m, to solve for the final velocity of cart 1. So take 1's final momentum divided by 1's mass, and that should give you its velocity. So go ahead and do that calculation and figure out what we've got. Take a moment. We can even pause it. Okay, hopefully you've paused, and you've unpaused. Let's look at what we actually get for the data. So, let me go back to over here. And now we're going to shade this region in. And I'll hit stats. And that's for 1. We want the red. Hit OK. And I don't know how well you can see this, but we've got, let's see here. Oh, it's this one here. There we go. An average of 0.31 meters per second, I rounded, and that's positive, positive 0.3. So see how well your data came out, and make a remark also on the online survey where you've put your answers. Okay? All right, so now we're going to pause.